everyone. I'm Feier Hou from Western Oregon University, and my talk tonight is about the things I do in my chemistry classes to make chemistry a little less scary to our students and to help them learn chemistry. So a lot of us probably have had this conversation before. We tell someone, "Oh, we study chemistry," and they're like, "Oh, I hated chemistry in school." Well, and judging by how many likes this tweet got, I'm guessing this is a pretty common conversation. So this conversation, although it can be slightly annoying sometimes, most of the time we can just let it pass. Well, however, if our student come to our chemistry class with the mentality that I'm just not a chemistry person, I just hate chemistry, then it's not going to be helpful for them to learn chemistry in our class. Because with that mentality, they're less likely to give their all to try their best, because, well, if you're just not a chemistry person, then why bother even trying, right? You're not going to get it. And they're probably also more likely to give up when they face challenges in learning chemistry, which is pretty common. You will have challenges when you're learning something. But if they have this mindset, they might think, see, this is evidence that I'm just not a chemistry person. Then they might just give up. So for students to have this mentality in a chemistry class is not going to help them learn chemistry. So what we need to do is we need to, especially for students, well, for all students, but especially for students who have the mentality that they're just not a chemistry person, we need to make our chemistry classes more accessible to them and help them see that instead of saying, well, they're just not a chemistry person, they are not a chemistry person yet. So in other words, we need to foster a growth mindset in our class to let the students know that their intellectual ability can actually be developed in chemistry with work, with effort. Okay, and so instead of they might feel like they are not a chemistry person, but in fact, as time goes on, as they learn chemistry, they are able to get better at chemistry. So there are many ways growth mindset is beneficial to students. For example, studies have found that it can motivate students, it can improve their performance, it will improve their perseverance when they face challenges in their learning. And it can also, especially for students who are underrepresented minority or from low-income backgrounds or facing stereotype threats, studies have found that having a growth mentality significantly improve their performance and can actually partially negate those things that have negative impact on their learning. And growth mindset can also improve student enrollment in STEM classes. So studies have suggested having a growth mindset intervention in our classes to foster growth mindset. There are other things we can do to help our students learn chemistry and to help them see that they are able to become better in chemistry. For example, we can make our classes more fun, more relatable, so that students can get more engaged, and they can also see how chemistry is related to things that they see in everyday life. We can be more approachable as instructors, so that way students are comfortable discussing chemistry with us and ask for our help if they're having difficulty. We can give students plenty of practice to help them learn chemistry, and we can encourage our students, especially if they're facing challenges, for them to see the challenges as opportunities for them to grow and encourage them to persevere. So those are all really good advice. Okay, those are all effective. Well, the thing is that what exactly are the actual things we can do in our chemistry classes? So in this talk, I'm going to present a few examples of the things I have done in my chemistry classes that help students learn and help them grow their intellectual ability in chemistry. So a little background on this. I just finished my second year as an assistant professor at Western Oregon University. So during those 2 years, I have taught the general chemistry sequence twice. I have also taught upper division classes, including physical chemistry, materials chemistry, and also lower and upper division labs. Our school is on the quarter system. So each academic year, we actually have 3 quarters. Each quarter has 10 weeks. So for the general chemistry sequence, for example, it lasts the whole academic year, which means we will have 3 quarters of general chemistry. So we call them general chemistry 1, 2, and 3. Okay. So the first thing I want to talk about is empathy. So being empathetic to our students, okay, which means we need to see our classes and our course materials from the student's perspective. So that way we can teach more effectively and explain the materials more effectively, more clearly to our students. So which boils down to we should teach the students in front of us instead of the students we want to have or we think we should have. So what that means is that, well, students in our classes will come with different levels of preparedness, both in terms of knowledge and in terms of study skills. Also, some students, not all students can devote the same amount of time or energy to our classes. Some might be less privileged. For example, they might have to juggle between a full-time job, family care, and being a student. So they simply just cannot devote as much time or bandwidth to our classes. So those are just an example of some of the difficulties our students might be facing that can affect their learning. So when we design our classes, those are the things we need to consider. Okay, that's part of being empathetic to students, is that we need to consider all those things so that we can make our classes more accessible to all students. So one of the most important things for being empathetic towards students is to communicate with them. Because by communicating with them, we can, it will help us see the course materials from the student's perspective, so we can see what is easier for them, what they find confusing, what they have learned from our classes, have they mastered our the main takeaway points from the classes, and also what are the difficulties they're facing. So that way, we can adjust our teaching methods to better accommodate all of our students and offer students more personalized help to help them learn chemistry. And communication does not limit to just holding office hours or just make a broad announcement that, hey, let me know if you have any questions. Communication should go beyond that. So in my class, what I normally do is I would reach out to students. So if I notice a student is struggling, I would reach out to them and ask them to meet with me and talk about what they are struggling with, what difficulties they have, what they find confusing, and then I can give them some feedback on what they can work on to improve their learning, or sometimes give them some study tips on how to study more effectively. And another part of communication is giving feedback. The feedback needs to be frequent. So in my classes, I have frequent low-stake assessments throughout the term, and as well as assignments after every classes. So on those, I can give students feedback on things that they can work on to improve their learning. So feedback should be on learning, not on things like intelligence or effort. Because if we give feedback like on intelligence, like, oh, you're really smart, that actually goes against the growth mindset, because that tells students that they're good at chemistry because they are smart, because of something that's inherent to them, instead of something they can work on. On the other hand, if we praise students for their efforts, so like for example, we tell students, you're doing your best, that is not helpful in improve their learning, because in chemistry, our goal is for them to learn chemistry, not for them to do their best. And also to master chemistry, students should not do that through brute force. So it's not like the more effort they put in, the better they will guaranteed to be at chemistry. So we need to give them feedback on learning, on maybe help them with some study strategies to help them learn chemistry. Well, so a lot of people think of empathy. When they think of empathy, well, maybe not a lot of people, but definitely some people, when they think of empathy, they might be thinking, oh, you're just being too soft on students. You're just giving everyone easy A's. No, empathy is not being soft on students or giving everyone easy A's. Quite on the contrary, we should always hold our students to high expectations, and being empathetic towards students just means we find effective ways to help them achieve those high expectations. So we should not sacrifice the rigor of our curriculum. We should not water down the content in our chemistry classes. But at the same time, we need to be flexible in ways that help students' learning. So for example, when we design our classes, instead of cramming a lot of content into the class just because that's how the class has always been taught, we need to think about, well, what are the most important points we want students to take away from this class, and focus on those points instead of cramming too much content into the class. Or another example would be we need to allow mistakes because, well, everyone's going to make mistakes. That's just part of learning, especially in the early part of the class. Students will often make mistakes. So we need to allow mistakes in class. And one example of that is in my class, I allow students to replace one of their midterm grade with their final grade if they have made improvement on their final. So that way, I allow students to make mistakes, especially in the early part of the class, without that having too big of an impact on their overall grade. So this way, this way, I encourage students to learn from their mistake and make progress, make improvement based upon their mistakes. So that is what being empathetic means. So I can give you an example that's something I did in my class that's based mostly on empathy, which are the assessments I give during the pandemic. So due to the pandemic, spring 2020 term was moved online. And one of the main concerns of online classes is about assessments. So part of the concern is how do we give effective assessments to students, and how do we give effective feedback through those assessments. Another part of the concern is, well, online assessments, since a lot of times they're not proctored, there might be increased amount of cheating. So, well, to prevent cheating, there were certainly services like online proctoring service. However, I chose not to use that, and the reason actually comes from empathy. So online proctoring services can cause problems with equity. For example, students who have slow internet connection would be at a disadvantage with those timed online proctored exams. So online proctoring service is not really an equitable option for our students. So, and as an instructor, I know quite a few of my students are actually having that or other kinds of difficulty that would make online proctoring service would just not work for them. So what I chose to do was first having both formative and summative as assessments. So first, throughout the term, I have multiple low-stake quizzes actually, I have a low-stake quiz every week for students to, so those quizzes hold students accountable because, well, they have to finish the material within a week so that they can take the quiz. And also through those quizzes, through those frequent quizzes, I can give students feedback after each week. And similarly, each week I ask students to submit something called a minute paper. So a minute paper is like, it's the same idea as a Mattis point used in active learning, where I ask students to write about 3 key takeaways they got from that week's lecture material, and 1 point that they're still having difficulty. And by looking at students' minute papers, I can give them personalized feedback on. I can give personalized feedback onto each of them. So that's for the low stake type of assessments. And for the bigger, higher stake type of assessments, such as midterms and the final exam, I made them all open book. So for the midterms, I give students were asked to answer all open questions where they have to show their work and explain their answers. For the final exam, I asked the students to do 2 things. One was to make a concept map of each chapter. So they need to include all the key points of the chapter and make a concept map to show how the key points are related. So that's part 1 of the final exam. Part 2 of the final exam, I asked the student to write a paper that reflects on what they have learned in this term and their learning experience this term, as well as to how what they have learned this term can be related to their daily lives or their future career. And I should mention that having those type of assessment, even though it to a degree did reduce cheating. So like, for example, the final exam being concept maps and reflection paper, okay, those are some very personal type of assessment. So this really reduced cheating. Even though that did do that to a degree, it did not completely get rid of cheating. So the exams were not cheat-proof. But that was really not my goal of having those exams. So my goal of having those exams was one, like I said in the beginning, based on empathy. So I would like to have exams that are more equitable to all students. And 2, okay, by having those exams, I want to have assessment that are more authentic to students, so students, instead of just answering some standardized multiple choice questions, they will be assessed. They will need to use what they have learned to solve problems creatively. So this type of assessments should be more effective than just standardized test that test students' memorization of the course material, for example. So here's an example of the concept maps my students have made. So as you can see, okay, to make a concept map, students really have to review all the key points of each chapter, which was really just the point of having a final, is for students to review what they have learned. And also, when they make a concept map, okay, after they reviewed all the key points, they have to find how they're related. So for example, on this concept map made by this student about chemical equilibrium, the equilibrium is a dynamic process, so the reaction didn't stop. And so if you change the condition, the equilibrium can shift. And in which direction the equilibrium shifts we can tell from either the reaction quotient or using the Chatelier's principle, and those are all related. So here are some excerpts from the reflection paper, which is the second part of the final exam. So students, so the excerpts shown here shows what students think what they have learned are related to their everyday life or their future career. So this student talk about what they have learned in chemistry class, how what they have learned in chemistry class can relate to their everyday life. So they discussed how indicators work when their dad was working on the fish tank maintenance. And this next student talked about how the problem-solving skill is important for their future career, which is a physical therapist. And then the student another student talked about, well, this student is an earth science major, and this student talked about how chemistry, what they learned in chemistry can relate to earth science. For example, they can use chemistry to learn the chemical registries of planets. And this other student wants to be a pediatrician, and they found that what they learn in chemistry can help them understand effects of certain drugs on children. So from those excerpts of the reflection paper, having students write this reflection paper, especially having them write about what they think chemistry is related to their daily lives and their future careers, really made them think of chemistry in the context of real life and in their future career. So that really makes chemistry more meaningful to them. So since those are assessments, okay, how effective are those assessments? Because one of the concerns I actually had initially was, well, would those assessments be too easy on students? So I'm going to show you how effective those assessments were. So as I said, this was assessments for general chemistry students in spring 2020 term. And that was the third term of general chemistry. So that was general chemistry 3. So the same class of students already took general chemistry 1 and 2 with me in the fall and winter term. And both of those terms were in person. So the exams were all closed book proctored exams. So here are the grade distribution of general chemistry 1 and 2, which were the 2 terms that were in person and with closed book proctored exams. And here is the grade distribution of general chemistry 3, which was the term that was online and used the open book exams I just showed. So I should mention that those are the overall grades. These grades include both the open book exams and all the assessments. So all those grades were overall grades. So as you can see, the grade distribution did not change significantly going from closed book exams to open book exams. And the class average were actually pretty similar to the class average from the previous 2 terms. In fact, it actually decreased a little bit compared to the second term. So having those open book exams were not making things too easy to students, as evidenced here by the similarities in the grade distribution. And in addition, having those open book exams during the pandemic really offer a more equitable option for our students, because those open book exams, they do not really require a fast internet or any fancy technology. In fact, I actually told my students they can submit their work in different ways. They can just write that on paper and just send me a picture if they do not have reliable internet, for example. So having those open book exams were developed based on being empathetic towards students and consider the difficulties they might be facing, and they're likely a pretty effective assessment method in general chemistry. Well, at least as effective as the closed book proctored exam in the previous 2 terms. And well, I'm also going to show you my student evaluation results to show as part of showing the effectiveness of being empathetic towards students. So before I go too deep in this, I understand that student evaluations are often biased. Okay, so they should not be used as the only thing to assess to show teaching effectiveness. Well, however, at least they at least show some truth in how effective my teaching was. Okay, so even though we should not use student evaluation entirely to show teaching effectiveness, they can reflect in some way how effective the teaching was. So here are the summary of the student evaluation for that general chemistry class throughout the whole year. So the top bar is the points I have got for my class. The middle bar is the mean evaluation points of all courses in the chemistry department, and the bottom bar is a point for all the classes all instructors got of the entire university. So as shown here, my evaluation score was either the same or higher than both the department mean and university mean. The response rate was actually not too low. They were not over 50%, but I did get a good amount of responses. And it was not just because the grades I gave high grades, and in fact, compared to the second term of general chemistry, the third term of general chemistry, the class average grade was actually lower, but the evaluation score was higher. So it was not entirely because the grades were good. And here are some excerpts from the student evaluation comments. So I have redacted part of it, the part that contains personal information. But other than that, those were the real excerpts. So several students mentioned that I reached out to them, and that was really helpful. And in fact, among all the students I've reached out to, several of them showed improvement in their performance. The most significant improvement was someone went from a 60% on the first midterm to an 82% on the final exam. So reaching out to students were helpful to students, as shown by their comments. And one student mentioned it was great that they were able to ask questions. And this other student also mentioned that I was available, so they could ask questions. And most of them mentioned it was helpful to have an instructor that's understanding of their conditions. So just in case you're thinking I only picked the most positive comments here, I'm going to show you some of the word cloud I made of all the student comments of all three terms. So based on the word cloud, the word helpful or help were high on in all three word clouds. So that was used frequently by students throughout all three terms. And from the word cloud, it looked like students rated me, at least pretty objectively. So the next thing I want to talk about that I use in my class is humor. So, a lot of us probably already use humor in our classes. A lot of us would crack a joke when we're teaching, right? And humor, as it turned out, was actually pretty effective in helping students to learn. Because, for one, it gets students' attention. Okay, and also humor can humanize the instructor and lower students' stress level. And also it has been found that it can actually improve students' performance, and it is also helpful to build the relationship between the instructor and the students, as well as the relationship among students themselves. So appropriate humor were actually effective in helping students to learn. So here I should note that appropriate is very important when we use humor in our classes, because and appropriate does not just mean the content of our jokes should be appropriate for class. It also means the amount of humor should be appropriate, because if you use too much of humor, it can be distracting as it has been found. So humor can actually have those benefits on teaching our classes. Well, but humor, and so when we think of humor, okay, we often think of things like jokes or internet memes. It actually goes a bit more than that. And jokes and memes were great, okay? They're great. I use them a lot in my class as well. So like, for example, I tell my students cats have paws, so cat ions are positive. Or when I taught statistical thermodynamics, this is the equation for the mean energy. So I made the energy really mean. Or when I taught catalysts to students, I used a cat that's to the right of the trunk chart of cats and use that as a catalyst. So when a catalyst is applied, it's like I place this big cat on top of the activation energy barrier, and because the cat is so big, it flattens the barrier. So this is just like how catalysts work. It speeds up the reaction by lowering the activation barrier. Or when I was teaching about buffer, I made a 3-panel meme that basically shows the key points of buffer. Buffer is a solution that resists change of pH by neutralizing any added the small amount of added acid or base, and the pH of the buffer can be calculated by Henderson-Hasselbalch equation. So I use memes and jokes a lot as humor in my class. But humor actually does not stop there. Another part of humor is use seemingly ridiculous, or I should say non-traditional problems. So for example, when I taught students of heat curves, so things like the heat released when so heat released or heat absorbed during the freezing or melting, or heat required when the temperature of an object is increased. So when students were learning that as part of thermal chemistry, we worked through this problem. So I saw this problem. I saw this first on the tweet, on one of the tweets by Nathan Pyle, and he proposed a combo sport called hockey by the eventually water polo. So they just keep turning the temperature up, so all the hockey field will just melt. So in that context, students calculated how much heat is needed to actually melt the whole hockey field. So we had to make a lot of assumptions, but this was a practice for students to calculate heat of melting and heat when ice was heated to the melting point, and when water was heated from the melting point to room temperature. Another example was when I was teaching about buffer solutions. In one of the practice problems to calculate the pH of the buffer after the addition of a small amount of acid or base, I gave it a context that instead of just saying the acid was added to the buffer, I said, well, the acid was added to the buffer by a cat. The cat knocked the test tube of acid into the buffer while making eye contact with you. That's a pretty typical behavior of cats. So those problems, they look ridiculous. But the point of having those problems is that it gives a context to the abstract concepts and formulas students learn in chemistry class. So instead of just saying, let's calculate the heat of melting, for example, it gives a context of we are melting the entire hockey field to make water polo. So this way, it makes the concepts and the formulas less abstract, and students can actually visualize how those concepts and formulas work in certain case scenario. And non-traditional problems do not just stop there. We can actually use non-traditional problems to develop some, to give students some problems that requires a little bit of exploratory work, or sometimes even a small mini research project. So when I taught ideal gas law in general chemistry, I actually heard this on a podcast that to stop a killer asteroid, one way is we can heat up a gas to very high temperature. And because PV equals nRT, when temperature goes up, pressure goes up. So when the temperature of the gas is high enough, the pressure will be high enough to push the killer asteroid away from hitting the Earth. So when I taught ideal gas law, I did a little brainstorm for the class to discuss how we can stop a killer asteroid using the ideal gas law. Students actually eventually figured out we can use the pressure of the gas to push the asteroid away. And through this process, the ideal gas law went from this abstract formula PV equals nRT to a more to a way that students can actually visualize. And so this problem gives students context as well. And further, students, by discussing this problem, students have to solve this problem creatively, okay, which involves some higher level cognitive activities like analysis and problem solving. Another example is something I did in my physical chemistry class when I taught colligated properties. So liquid water have been found on Mars, but Mars is really cold. So for water to stay liquid, that water cannot be pure water. It has to have a solute in it, or several solutes in it, for it to lower its freezing point enough for it to remain liquid on Mars. So in physical chemistry class, I first assigned the student to read a paper that's related to this topic. And then in class, we discussed how salty the water has to be to remain liquid on Mars. So from that paper, it looks like most of the solutes should be perchlorate salts. So we made the assumption that magnesium perchlorate was the only solute. And we also made further assumptions that the formula for freezing point depression still holds, and the Van Hoff factor is 3 for magnesium perchlorate. So based on those assumptions, students calculated the molality of magnesium perchlorate in water for that water to remain liquid on Mars. And they didn't stop there. They look at their result and ask themselves, well, did that make sense? So as it turned out, this molality is higher than the solubility of magnesium perchlorate in water. So the result actually didn't make sense. So then we had a discussion of why this result didn't make sense. So they went back and examined their assumptions, and they realized, well, we actually made a lot of assumptions that may not be valid. So our result will be a very crude estimation. And further, there might be other factors too, because the atmosphere on Mars is very different. The environment on Mars is very different than that on Earth. So that might affect the water remaining liquid. And some of those factors we do not even know yet. So this is another example of a non-traditional problem. So this problem, it gives students a context on this abstract equation for freezing point depression, so that they can actually visualize how it is applied in a case scenario. And further, working this problem almost turned into a mini research project, because students had to had to really examine their results and analyze what was causing this discrepancy, and went back and examined their assumptions. And some students did some further reading on why those assumptions were not valid. So like, for example, someone found that this equation actually did not hold for very high concentration. And also we also should not make the assumption that the Van Hoff factor was 3. So this kind of problem has another benefit, which is it can really promote students thinking, make students think. Okay, they can make them and make them solve the problem creatively using what they have learned. Okay, which really help them learn chemistry in a context, and help cultivate their problem solving skills. So I'm going to give an example of how effective those non-traditional problems are in class. So in one of my general chemistry class, which this was actually the first time I taught general chemistry at Western Oregon University. So the first time I taught buffer solution, I did it in a more straightforward, traditional way we just did practice on some more abstract problems that I took directly from the textbook. So there's this question on the second midterm asking students to calculate the pH of the buffer after the addition of a small amount of sodium hydroxide. The average grade on this problem was a 54%, which really wasn't that great. And because of that, I went back and revisited this concept with students. But this time, I taught it in using humor, the memes I showed you a few slides ago, as well as non-traditional problem. So I taught it in the way, in the context that the cat knocked the acid solution into the buffer. And so on the final exam, students were given a similar problem where they had to calculate the pH of the buffer after the addition of a small amount of sodium hydroxide. This time, the average grade on this particular problem was 88.3%. So that was a huge improvement compared to the first time they were given this problem on the second midterm. And I should also mention that the average grade of the second midterm and the final exam actually didn't increase that much. So, so that means compared to an average question on both the second midterm and the final exam, students made a much more significant improvement on this question compared to other questions, on this point compared to on this concept compared to other concepts. So, so that means so this shows us they are using non-traditional problems and humor does correlate with a significant improvement in students' performance. And I should also mention that this is really a work in progress. So I do not. So this will look like this is just one data point. And as of now, I do not have more data point to support this. But from just this one example, it does show that in this particular case, using non-traditional problems, which means giving the abstract concepts a context, did correlate with a significant increase in students' performance. So last thing I want to talk about is active learning. So active learning have been found, especially in recent years, have been found to be really effective in improve students' learning because it gets students more engaged, especially engaged in higher order cognitive properties like analysis or problem solving. It can promote critical thinking and it can improve students' performance by improve students' understanding of the course materials. So active learning have been found to be very effective in improving students, in helping students learn the material. But there are some resistance in implementing active learning in classes. Well, some people might say, I just don't believe in active learning. And there were actually a paper that showed that claimed that, well, it's actually premature to claim lecturing is an inferior type of education. And to be honest, I get it. Okay, active learning can seem a bit overwhelming to instructors, especially instructors that are implementing active learning for the first time. Some of the active learning strategies will require a lot of work, and the results might vary. Okay, depends on how you implement those active learning activities. Some may be more effective than others. So what if I did all that work and it didn't really work for my class? That is a concern, and I get it. Even for people who have successfully implemented active learning in their class, they pointed out that it is not realistic to go from lecture to active learning overnight. It's going to take a lot of work. It take a lot of practice to effectively employ active learning in the classroom. So for people who don't believe in active learning, or for people who are really just overwhelmed by all the work they have to do for active learning and the non-guarantee in the result, I would start with small activities. So what that means is that in my classes, I'll give some example I did in my classes. So in the material chemistry class I taught, one of the goals of the class was to be very career oriented. So for students to apply what they have learned in the class in their career. So with that goal in mind, I replaced some of the assignments, the homework assignments, with activities. So one of the activities they have to do is something called explain Item 5. So they have to explain magnetism, so why some materials are magnetic, to someone who's maybe 5-year-old. So they really need to break down the complicated concepts to something that's that a 5-year-old can understand. Another activity they did is an elevator pitch. So for this assignment, they were required to read on a topic about bulk metallic glass, and assuming that suppose they were the scientists that discovered bulk metallic glass and they need research funding, and one day they enter the elevator, there's this person that's from the funding agency. So they want to pitch their research idea to them in the hope of increase their chance of getting the fund. But because they're in the elevator with them, they only have 30 seconds. So their pitch has to be short. So they really need to summarize the key points of what bulk metallic glass are and why they're important. So have those assignments. So in those assignments, students get to practice some skills that are going to be useful for their future career. Another example is in my elementary physical chemistry class, which was moved online in spring 2020. So the lab was moved online as well. So I have to give students data for the lab. So in one of the labs on reaction kinetics, instead of just giving abstract data, I give them data I took from I can give them data of blood alcohol concentration versus time that I took found from literature. And from here, they need to figure out the reaction order, the rate constant, and predict the blood alcohol level after a certain amount of time has lapsed. And some other smaller active learning activities I have done in my classes include worksheets. So I could give students worksheets on with practice problems that they complete during the class. And then they discuss with other students. And then finally, we go over those practice problems as a class. In my class, I also sometimes use clicker questions. Those were really short questions, mostly multiple choice. And for the class that was moved online in spring 2020, since I was teaching asynchronously, I used the tool in my learning management system to implement pop-up questions in lecture videos, which were just like the clicker questions. So students will see those questions about every 10 minutes of lecture video. Those questions serve as a quick assessment of their mastery of the material in the video so far. So, well, another thing I did was in one of my upper division labs, we needed a lab on phase transition. So I turned this lab into a mini research project. So students were given instructions on how to measure the glass transition temperature and the melting point on differential scanning calorimeter. And then they were given 3 polymers, so PET and polyethylene glycol, polypropylene glycol. They were given those 3 polymers and asked to measure the glass transition temperature, the melting point, and for those 3 polymers. So after they do that, they need to examine the results and answer the following questions. Do all 3 show both freezing and melting and glass transition? And why are their results different from literature. And based on the results, why is it not a good idea to put hot water into a soda bottle which is made of PET? So students were so to answer those questions, students have to examine their results and look up resources, look up literature, and come up with a plausible explanation to answer those questions. So this lab turned out to be a very interactive lab where students form groups to discuss their results. And one student found it particularly interesting because his family did blacksmithing, and he found the supercooling, the quenching of polymers related to what they did in blacksmithing. So all those activities, they actually didn't require a lot of work. And in fact, a lot of those activities, we have to do that in our classes anyway. So like, for example, for this upper division lab, I have to have a phase transition lab anyway. So might as well turn it into a mini research project. Or for the worksheets in class, we have to do some in-class practice anyway. So might as well let the students do those by themselves and have discussions with each other. And for those worksheets problems, well, I can use those non-traditional problems like I just showed, but I can also just use the end of chapter problems from the textbook if I do not have the time or energy to write my own problems. So those activities, they actually do not require a lot of time or energy commitment, and they can be implemented into classes, even for classes that are using the traditional lecturing way. So like, for example, the worksheets, we can give worksheets into a class that was taught in a more traditional lecturing way. Okay, so this way, we actually do not have to redo our entire class. We can just give those activities into our class. So so that way they do not require a lot of our time or energy commitment, but they are still active learning activities that we can easily implement into our otherwise traditional lecturing class. So, I'm going to show you how effective or ineffective those active learning activities were. So, like I said in the beginning, I have taught general chemistry twice so far. The first time I taught it was in my first year, and I actually didn't know active learning at the time. So I taught the class in the traditional way by just giving lectures. So we didn't do any active learning in that class. So this is the grade distribution for General Chemistry 1 for that class. So the second time I taught General Chemistry, I have learned active learning already. So I designed some activities for the class, such as the worksheet, the clicker questions. So this is a great distribution for General Chemistry 1, the second time I taught it with active learning. So I should mention that the second time I taught it, the class was a lot bigger than the first time I taught it. So that's why all the bars seem to be twice as high, because the second class has twice as many students as first class. Well, however, even with that in mind, it looks like students who are earning A's there are more students who are earning A's with active learning than without active learning. Because without active learning, we have 3 students getting the 90 to 100%. With active learning, we got 14. So even after we take into consideration that the second class is twice as large as the first class, that's still an improvement. So from the grade distribution, it does look like grades shift slightly to the higher end with active learning. So it seems that the active learning activities were helpful in general chemistry, and that was also reflected in some of student evaluation comments. Several students mentioned the worksheets, the practice problems we did in class that they found were particularly helpful for their learning process. Well, but part of it is also ineffective. So this is also an excerpt from student evaluation. So this was from the material chemistry class, where I give students, instead of giving traditional exams, I give students activities to do, so activities and projects to do, and those use those to assess and use those as assessments. And as you can see, because we do not have a final exam, it's less obvious to students why we're doing those activities. So they just found that, well, there's no point in studying, even though those activities do count as part of their grades. So that was actually a problem that I had when I implemented those active learning, those activities. And that is a problem that I do need to address in the future by probably explaining to students why we're doing that, why we're doing those activities to increase the students' buy-in of the activities. So to summarize, so I talked about some of the things I've done in my chemistry classes that were helpful in students' learning and can affect and will hopefully be helpful for other people's class as well. So the first thing I talked about was empathy. So we need to be empathetic towards our students. We need to hold them to high standards, but we need to find ways to help them more effectively help them achieve those high standards by seeing the class from the students' perspective, so that we take into consideration students' conditions, students' needs to make this class more accessible to all students from all different backgrounds. Well, next I talk about humor, which include memes and jokes, but goes beyond that. And which means we did some non-traditional problems in the class to make the abstract concepts and formulas more, to give abstract concepts and formulas a context for students to visualize how they are used in certain case scenarios. And some of those non-traditional problems can even be turned into some more exploratory work or even a mini research project. And finally, well, I showed some active learning strategies I use in my class, which were which would be useful for someone who's just starting on active learning, because those were some activities that are on the relatively smaller scale that does not require a whole lot of time or energy commitment. And it does not require us to redo our whole class, and they can be implemented into a traditional lecture-heavy class. So with that, I would like to end my talk, and I thank everyone for coming to my talk.
That was absolutely fantastic. Thank you very much, Feier, for that presentation. So we have a number of questions. Before I get to those, I do want to say your memes are on point. They were fantastic, and I wish that you had taught my organic chemistry classes. I feel like I probably would have learned and remembered a whole lot more from them than I did. That was fantastic. Okay, so let's jump into the questions. So our first question is from Freddie B, who wanted to know if you have some examples of relating chemistry to the real world. So this was asked early on, so I know you kind of touched on some of them. But are there? Can you maybe talk a little bit about how you try and tie chemistry into the real world in your teaching?
Yeah. So the easiest way to do that is to include real world examples. So when we are so like for example, when we are learning unit conversion, I talked about the new definition of the kilogram,
Okay.
and or sometimes, or like when we were doing some experiments in the labs,
Mm-hmm.
I can talk to students about how like what we are doing in the lab might be related to can be related to what we see in in our everyday life. So like for example, when we're talking about things like density,
Mm-hmm.
so I can talk to students about how we can actually use density to tell different things apart.
Okay.
That's And also, like when we're talking about sig figs, I can give students examples of why sig figs are important. So because we want because in certain cases we do not need to be as accurate as in other cases. So that's maybe like the easiest way I can think of to include some real world practice into class just by giving real world examples. So some of the others I have already touched in my talk, which is to formulate questions, practice problems with a context. So instead of just asking, students to like plug in numbers into equations, we can we can give them a context of like how those equations are used. Like I already gave some of those examples in my talk.
Okay.
So yeah, so those are some of the things I have done to like make chemistry a bit more relatable to students.
Okay, very nice. Let's see. So our next question came from Alex Lynn, and he said this was talking about the student evaluations. Apparently, his university's physics department gives a bonus to all students whenever 90% or more of students fill out the evaluation form. And he wanted to know what you think about that as a way to boost the evaluation response rate.
Well, I have heard also some instructors would give students extra credits, for example, to encourage students to fill out the evaluation form. It can it can be effective, but if there's an extra credit, then they're more likely to fill out the form.
Sure.
But at the same time, it can also kind of skew the results a little bit.
Okay.
Yeah, it can, well, like for example, some students might think, well, I'm getting an extra credit, I should maybe say something a bit more positive just because I'm getting a bonus. So that's one thing I can think of. So I mean, it can work. It can effectively make more students fill out the evaluation form, but it does come with a slight risk of the results might be a little bit biased.
Okay, that's a good point. I hadn't thought about that. What do you think about doing? I taught a chemistry lab for about a year and a half at the University of Texas, and one of the things that we did is that we actually gave the students we gave them the review the class review forms in person, and so we actually took time out of one of the classes towards the end of the semester. And, and obviously the TAs and I all left and went into a different room and all that. What do you think about doing that versus say like an online review? Obviously, right now that's not really an option, but let's say in a more standard time. What are your thoughts on that?
I have actually done that before. So before I came to Western Oregon University, I was an adjunct professor for 1 year at North Carolina Wesleyan College, and that's how they did the student evaluation there. By giving students like actually hard copies of evaluations for them to fill out in class. And I, as an instructor, I had to step out of the room when they're doing that.
Yeah.
So after it's done, one of the students will collect that into a sealed envelope and bring that to there's a person in the library that's collecting that. So bring that to the person. So I actually have done that before, and I have also done this. Have also received this online evaluation. So I would say with the in-person hard copy type of evaluation, I mean, I would think students were more likely to fill out evaluation forms. And indeed, like they what I found is that they were more likely to fill out the part of the form that were multiple choice.
Sure.
But they were actually not more likely to write comments on the forms.
Oh.
So yeah, so they I didn't really receive that many comments when we were doing the in-person hard copy type of evaluation.
Okay.
Well, I didn't receive more comments than I did for online evaluation. So
That's
they were
interesting.
more likely to fill out the forms, but only for the multiple choice part. That's my experience.
Okay, that's interesting.
Yeah.
Okay, very cool. Let's see. Alex had another question. Was what are some milestones or markers that you use to make sure that you're not being too empathetic, or that you're not lacking empathy in your courses?
That's a good question. Um, yeah, well, I mean, there are certain things that we like we have to hold students accountable, right?
Mm-hmm.
So like we cannot just give everyone easy A's, or like, oh, you're having difficulty, oh, don't worry, I'm just gonna give you an A and call it a day. Like
Yeah.
we can't really do that, because that's not really learning. But we also shouldn't be like too rigid and just be like, well, the deadline will not be extended no matter what, even if it's the end of the world tomorrow. We are not extending the deadline. Like
Yeah.
we also shouldn't do that. So I think ultimately it all boils down to what will help students learn the most. So
Okay.
and it kind of varies from student to student, and from case to case as well. Like in some cases, I can be a bit more flexible, but in other cases I cannot.
Mm-hmm.
So really my only uh kind of like my only like yardstick on this is to see like which what I should do to help students learn. So if being flexible, if giving students an extension will actually make them sit down and think through the assignments instead of just like rushing through it and fill in the answer, then I will give students an extension.
Okay.
Or well, on the other hand, if like giving students an extension, they are just going to like slack even more, then I would not give that extension. So really, it depends on what I should do to really maximize their learning.
Okay.
Yeah.
That's a good answer. So I guess I'd like to. I'll piggyback off of that one real quick before we get to the other questions. How do you, um, or I guess, have you had any experiences where you've had a student with some kind of mental illness? And to give an example, I had a student who had depression, and at one point, this was in the lab course. At one point, he basically didn't show up for like a week. Um, and then this was a lab course at Met. I think I forget now. I think it was twice a week at that point. And he he basically no showed, no nothing, and then came in and said, hey, I basically had a major episode where I had no drive to even get out of bed. How do you factor something like that into the adjustments that you kind of make that you've talked about with this?
Mm. Yeah. Well, I mean, I generally would like kind of err on the side of being more empathetic than less.
Sure.
So generally, like I would be understanding of students, especially students with mental health problems.
Hmm.
And I have had a few students with similar problems. And what I normally do was that I would give them accommodations as much as I can without affecting their learning too much. So, like for example, if a student uh, couldn't show up to the lab due to depression,
Hmm.
what I could do is, well, I could either like scale the lab grades of their other labs to make sure they did not um, it does not affect their grades too much,
Okay.
or I could give them another practice to do in place of the lab.
Okay.
So like the practice might include the same concepts involved in the lab,
Hmm.
and so they still get the practice even they didn't really show up to the lab.
Okay. Let's see. So, okay, Infinite asked, how applicable are your strategies in subjects that are less mathematically intensive than chemistry? Examples given were biology and anthropology. And do you think that the strategies you've described are universally serviceable for students studying different subjects?
Hmm. Well, I mean, just like everything else in science, I cannot say 100% yes.
Sure.
Yeah, but I think they will be universal. They can be adapted to other subjects as well. So like for example, the ways I used non-traditional problems, like problems with a context. Well, in other subjects, well, we also have some pretty abstract context as well. And to students, especially students who are first learning those concepts, those really are just those would remain just words from the textbook. If they're only done problems that are really more in a more abstract way. So in other subjects, we can also use give context to like abstract problems and use like real world examples in the practice problems. And in fact, a lot of the references I had on my slides were actually not chemistry specific. They were actually, some were from other fields, some were actually in just like more general type of education papers. Yeah, so like actually most of the references, a lot of references I have were actually not chemistry specific. So like being empathetic towards students or using non-traditional problems or using active learning in classes, they could be effective in pretty much all the fields, not just chemistry.
Okay.
Yeah.
Yeah, I think that's a good point. Let's see. Okay. This is a good one. Alex asks, "Do you have any suggestions on implementing active learning for asynchronous classes?" I know you had kind of touched on that with the pop up questions during the videos,
Mhm.
but he makes a good point. That's especially again right now, but even
Yeah.
in for other online learning,
Mhm.
sometimes students don't watch lectures at the time due to time differences or other obligations.
Mhm.
So how can we try and implement the active learning for asynchronous classes?
So I should say that this is still something I'm working on because at this point I do not have a final plan for my asynchronous class yet,
Okay.
and I think a lot of us are also still working on our online classes.
Yeah.
So in the spring 2020 term, well, due to the time constraint, like the class was moved online within like a week of notice, so I couldn't work too many of active learning into my asynchronous class.
Hmm.
So one of the things I did was that pop-up question I mentioned in my talk. Well, another thing was was just like in the online labs by giving students data from like real world case scenarios instead of just like making up some data. Um, and so moving forward, actually for my fall class, which will also be taught online asynchronous, I am considering a few options, such as having some small projects for students to collaborate on. So on the learning management system, so we are using Moodle currently. We can have forums for students. So I can ask students to like work on maybe like a small project, and every student needs to contribute to the project. So every student has to post on that forum on that
Okay.
project, and that counts as part of the grades. So that's one thing. Another thing I'm thinking of, and this is probably a little less active learning, but more like building the community, building an online community, is
Okay.
every week, each student should ask a question, and each student should also answer at least one of their classmates' question every week using that online forum.
Hmm.
Um, so uh, so this way, so this is another way to maybe kind of like promote students' discussions of
Okay.
of some common problems, and I can monitor that forum to jump in if students are like stuck, for example.
Okay.
Um, so I think like most learning management system will have this kind of forum, or even if they don't, well, we can always just use something like Google Doc.
Okay.
Um,
Yeah.
yeah, so that is that. So I mean, I haven't got everything figured out yet, but that is something I'm considering doing this fall.
Yeah, that's some interesting ideas. I like that. Yeah, it can be difficult to it can be difficult to get creative.
Mm-hmm.
Okay, so Aleph wanted to know. I think this was during the active learning segment.
Mm-hmm.
How did you kind of showed the grade distribution? Were there any other ways that you measured the effectiveness or ineffectiveness of the active learning?
Um, so well, I also showed that in some of the student evaluations, because some of the students, so the several students mentioned the active learning I did in class, and they said they found it to be really helpful. So the grade distribution and student evaluation comments were really the two main ways I used to assess the effectiveness of active learning.
Okay,
Yeah.
that seems like a good way to get the feedback on it, especially student reviews where you have the
Mhm.
comments saying specifically. You may have mentioned this. I'll piggyback off of this one real quick. So forgive me if you did. Do you ask them, like I know in the reviews that we did, we had what were effectively blank questions, and we could ask our own, and so we would normally ask them to say, something like, tell us something that you really liked about the class, tell us something that you really didn't like about the class.
Mhm.
Are your online reviews set up like that as well?
No, we could not ask our own questions.
Ah, okay.
So, but well, I mean, that being said, we could always like give our own evaluation forms. Like in my very first class taught, I gave a midterm evaluation.
Hmm.
And I asked just exactly those questions. What do you find helpful? What did you find not helpful in this
Okay.
class? What would you suggest to improve? So I asked just those questions. So and well, and also in the spring 2020 in the reflection paper, students kind of answer those questions when they reflect on their learning experience of the term.
Hmm.
Um, so there are ways to know that if you want to know that, but we do not have that option on the school-wide formal online evaluation form.
Okay.
Yeah.
All right. So Infinite has another question. This is a good one, especially right now. It says that several professors he's talked to are somewhat trepidatious about the new academic school year that's starting. In particular, they're worried that the pandemic and that the lack of structure during the summer has caused complacency and stagnation, stultifying the minds and curiosity of students. And he wants to know, in your opinion, are those concerns valid? And if so, what advice would you give to both students and professors that have such concerns?
Hmm. Well, I mean, I understand why people have such concerns. They this is not an easy time for everyone. Like we this is a time with a lot of like uncertainty, a lot of
Yeah.
chaos really to both professors and students. So and like both professors and students might be facing some difficulties that they would not have to face when during like a normal school year.
Sure.
So like I understand people having such concerns. So one thing I did find very effective in my online class back in spring 2020 was students really like to have structure in class.
Hmm.
So like I mean like I know I talk about being flexible about deadlines, but that does not mean you can have just deadlines like everywhere. So students really like to have for example like the deadline always being on the same day of the week,
Hmm.
and like on like uh in the online class on the website clearly mark out okay, these are the videos you need to watch this particular week, these are the assignments you need to complete in this particular week. So like
Okay.
label like the things they have to do each week. And students really, several students have made this comment in my evaluation this year that they really like that the class is really structured, especially during a time with a lot of uncertainty.
Mm-hmm.
Having something that's so ordered, so structured is kind of just like something they can hold on to.
Yeah, I get that.
Yeah.
Yeah. That's smart though. I like the way you're balancing, like you said, you kind of have the borders that are set up, but within those borders, you show a lot of willingness to, like as you said, be flexible and kind of figure out what works best for each student. I think that seems like a great way to teach.
Yeah.
Yeah, that's fantastic. So I think that's all the questions I've got from chat. I'll give them a few more, a little bit more time in case they want to ask any. But yeah, this was, like I said, I was looking forward to the talk, and it was even better than I had hoped it would be. This was really interesting.
Thank you.
Yeah, because especially I appreciate the way that you kind of tied everything in, and I especially appreciate the way that you showed some data to kind of show like, hey, this, I've had these ideas, I've incorporated them from, an education research background, but I'm also checking to see if they're actually doing what I want them to do, and that's a really nice thing to see.
Thank you.
Yeah, it was a fantastic story, and I could tell you, I mean, just based on the number of questions you got, you were very the presentation itself was very interesting and elicited a lot of feedback. So that's always a good thing to see.
Thank you. I'm glad to hear that.
Yeah, absolutely. All right, it looks like that's all the questions we've got, and so I'd like to thank Dr. Feier Hou. Like I said, it was a wonderful presentation. I really appreciate you taking time out of your schedule to give it.